All right, so I think this is recording. Let's take a look at this problem. They give us two functions, f and g, and they ask us to determine yes or no, are these functions inverses of each other? So that means that, and they're asking us to do this by verifying, by determining the function composition, f composed with g and g composed with f. If those are both equal to x, then yes, they are inverses. If they're not both equal to x, then no, they are not inverses. All right, so let's find f composed with g. Which means that the input of f is the function g. So the input of f is this fraction x over 1 minus x. So what does this function f do to the input? This function f always has a 1 in the numerator, and in the denominator, it always takes the input, no matter what it is, and adds 1 to it. Well, this time, our input is x over 1 minus x. So here we have a fraction within a fraction, but it's a little more complicated than our previous ones. So here I'm going to multiply this by the number 1. But I'm going to be clever in how I write 1. I'm going to write it as 1 minus x over 1 minus x. To multiply fractions is really easy. You just multiply straight across in the numerator and straight across in the denominator. It's much easier than adding and subtracting fractions. So here we just have to be careful with this multiplication. In the numerator, 1 times 1 minus x, we're just going to get 1 minus x. But this 1 minus x in the denominator, I have to distribute it to both of these terms. So let's write this out. Let's not go too quickly and cancel things out until we see what's being multiplied. So this first term is x over 1 minus x. And it's getting multiplied by this factor of 1 minus x. The second term here is 1, and it is also, by the distributive property, it's also getting multiplied by this 1 minus x. So now our goal is to try to simplify this denominator. Well, this first term here, I can see that this 1 minus x and that 1 minus x cancel. And I have just x. And here, multiplying 1 times this binomial, we just get that binomial back, 1 minus x. So I can see that this term x and this term x cancel each other out. And so what I'm left with is 1 minus x. Now, since that's not equal to x, I know that these two cannot be inverses. What I don't know is if when you did this problem, did you find f of g of x first, or did you do the other composition? So suppose you did the other composition. Because if I've done this one right, if I've done this f composed with g right, I can immediately, right now, I don't have to go any further, I can conclude that these are not inverses, that my final answer is no. These are not inverses. But just because I know somebody in the class may have found this one first, let's go ahead and do it. And I'm expecting this to not equal x. So this time f is the input into this function g. Well, this function g always creates a fraction where the numerator is always the input, no matter how complicated it is, and the denominator is 1 minus that input. This time our input is 1 over x plus 1. So we need to take this complex fraction and clear these denominators. I'm going to multiply this by the number 1, but I'm going to write the number 1 as x plus 1 divided by x plus 1. When you multiply fractions, it's very easy. You just multiply straight across the numerator and straight across the denominator. So these numerators are inverses of each other, and they have a product that's just 1. Now, this x plus 1, by the distributive property, I take it, and it multiplies both terms here. So let's write that out. Here, this first term is 1, and it gets multiplied by x plus 1 because of the distributive property. And then we have the second term, 1 over x plus 1, and it gets multiplied by x plus 1 because of the distributive property. And let's give myself a little bit of room here to continue. And let's try to simplify this fraction. So in the denominator, 1 times this x plus 1 is just going to give us x plus 1. And here, these guys are reciprocals of each other, so their product is just 1. This x plus 1 cancels with that x plus 1. And this reduces to 1 over x. But since that's not equal to x, then I know that these are not inverses, not of each other. Okay, so I hope that helps, and I will talk to you later. Bye.